Hello statistics and welcome to 13.2. This is the last chapter we're going to cover, and this one here's a sign test, which is something new. We're not going to do 13.1 or the last one. We're only going to do 13.2 and 13.3. So make sure you have your notes out and you have your stat disk open. Let's go. All right, the sign test, we can do it with three different ways. So we can do it with a matched pair, we can do it with nominal data, and we can do it about the claims about the median of the population. So these are three separate things, all right, that we can do a pair with, or matched, or a sign test with. And we'll be looking at all three. The key concept to introduce the sign test, it involves converting data values to positive and negative signs. So it makes life a little bit easier. We don't care anything about positive and negative or how they differ from each other. The sign test is non-parametric, so it's distribution free. The negative signs to test different claims, including matched pairs, which we talked about, nominal, and the median. So when you do this, we assign positive and negative values and discard any zeros. So first we look at, we will be doing examples of these also. We let n equal the total number of signs. The test statistic x equals the number of less frequent signs. So the test statistic is less frequent. That's very important. It's the least of the two, not the most. Okay, do they contradict the null or contradict your alternative hypothesis? Sometimes our null is rejected, but it does not confirm our alternative, and we'll talk about that. If n is less than 25, we have to find the critical value. We'll actually be using StatDist to find this. If it's greater than 25, we'll use our test statistic and our critical value. We will also, be using StatDist to find those. We will not be calculating them by hand. All right. Is the test statistic less than or equal to the critical value? So if it's less than the critical value, we reject the null. And if it's not less than, we fail to reject the null. Here we go. All right, we're going to do not matched pairs, nominal with two categories, and a median of a single population. When you go here, this is important. Your notation x is the less frequent sign, n is the total number. All right, they must be a simple random sample. That's the only requirement we have this time, so that's fairly nice. If we have less than 25, we use x as the number of times the less frequent sign occurs. Very important. If it's greater than 25, we're going to use the test statistic, and we'll use StatDist to find that. We will also use StatDist to find the p-values and the critical values. Remember, x is the less frequent. Very important. All right, one thing you have to be careful of, and we mentioned it a little bit before, is when you're using a one-tailed test, which this one is, it's not a two-tail, you have to avoid making the wrong conclusion. So if we say we reject the null, so it's not equal, that does not necessarily mean that the alternative is true. Because if we have less than and it's actually greater than, then that's a false statement. So we have to double check what we're concluding. So let's look here. We have 945 couples who use XOR. We've talked about this before. 66 boys. So they had 66 boys out of 945, or 0.0698 were boys. The claim that XOR method gender selection increases the likelihood of boys. So I am claiming that increases the likelihood of boys, or that it's greater than 50%. So this is my alternative, right? My alternative is what I am claiming is true. So that means my null is that p equals 0.5. Because remember, our null is always the equal sign. So now the sample proportion of 0.0698 contradicts the alternative. So it's not greater than 0.5. So when we do this, we're going to find out that we reject the null, which usually means we have sufficient evidence to support the alternative, but this time it is not true because it's in the opposite direction. All right, since this said p is greater than 0.5, but we only got 0.0698, it is the opposite that we have proved. So we cannot say this is true. We also cannot say it's the opposite because that is not what we are trying to prove. We just cannot support our claim. All right, Pause and try yours. All right, when you looked here, let's see if I can get this moved back up. Our null was that equal 50%. Our alternative was greater than 50%. So we're saying over 50% have blonde hair. But when we did our math, we had 13 out of 58, which is probably not the same number you had because you have different data, but it should be close. And you got 0.22413. This is absolutely less than 0.5. So even though I rejected the null at the beginning, I cannot conclude that my alternative is true because 0.22 is less than 0.5. So we cannot conclude the majority of students have blonde hair. We also can't say any more than that because we did not try to prove that. All right, let's move on to matched pairs. So now we talked about what we have to be careful of. Okay, a matched pair, we have to subtract each value, the second variable from the corresponding value of the first variable. Okay, and we record only the sign. So if this, and we record positive or negative, and we're going to ignore zeros. So let's look at our age difference here. We have our best actresses. So we have the girls here. So we have the female here and the male here. And we just record the differences in age. So this is what their difference in age is, as positive or negative. We are going to ignore any zeros because that's not going to, it doesn't affect our data one way or the other. Okay, now we checked our requirements. They're satisfied. It's a simple random sample. There's no difference between age of actresses and actresses is what we're trying to prove. So we count the number of positive and negative signs. This should be approximately equal if this is true. Okay, we have 2 positive signs and 7 negative signs, and 1 no difference, so this one doesn't count. The null hypothesis is that there is no difference. Okay, the alternative is there is a difference. So now this is what we're going to prove with our sign test. So now we go through and we count how many things we have. We have 9 that we're looking at. 2 is the smaller, so the x is 2. And the sample data do not contradict H1 because there's a difference between 2 positive signs and 2 negative signs. The sample shows a difference, all right, is what we're looking for. Does the sample show a difference? We need to continue with the test to determine whether that difference is significant or not. So what we do here, now we're going to go to our stat disk. So make sure you got stat disk open. Here we go. You're going to go to analysis. Now if you go down, you see the sign test. So click on sign test. And we have a given number of signs this time. So this is the one we're on. All right, we're looking here. The difference is equal to 0 is what we're checking, so that's correct. We have a 0.05 significance level. The number of positives is 2, so we need to change that. Our positives, I'm sorry, is 7. My numbers went away. And my number of negatives is 2. Okay, once you have that all in, hit evaluate. All right, now when we look here, we got to look at our test statistic. We have the number of total values was 9, which is correct. And we have a test statistic of 2 and a critical value of 1. So you need to write both those down. So now let's go back to our notes. So now when we're looking at this is a left tail test. This is very different. This is a left tail test. So when we look at this, we're going to draw in our graph. All right. Our critical value was 1. Our test was 2. So this is the critical value. This is our test statistic. Our rejection area, since this is a left, is over here. All right. Since our test does not fall within our rejection area, we fail to reject the null because this is the rejection. So we fail to reject the null, which means there's no significant difference. I mean, it looks like there is one, but there is not. All right, now it's your turn. I want you to do the cost of repair of a car. Let's see what you come up with. All right, when you type this into StatDisk, you should have got some weird stuff. The first one would have been that your test statistic was 0, and so was your critical value. Since those are equal, this is something we haven't had before, we actually reject the null. Okay, because we're rejecting the null, that means our alternative is true. So there's sufficient evidence to support the claim that there's a difference between the two shops. I hope you did well. All right, now let's go on to the next. So now we're going to go on to nominal data. So this is our second category that we're going to talk about. So nominal data, and this is always between two categories. All right, so the nominal data limits the calculations that are possible because we don't have anything to look at. We can identify the proportion of the sample data that belong to a particular category. That's about all we can do. Then we can test the claims about that proportion. So here we go. We have nominal data. We're just going to use gender, boys and girls. We use the sign test is used to represent girls with a positive and boys with a negative. All right, and this is just how you were born. So now we look at our gender selection, and we're going to look at Art of Genetics Institute and conduct a trial. All right, before the clinic trials were concluded, 879 of the 945 babies born to the parents' method of gender selection were girls. So we have 879 that were girls. We want a 0.05 significance level. We had 945 total babies we're looking at. All right, we assume the sample data are simple random samples, so we checked our requirements. Our null hypothesis is it equals 0.5, and our alternative is that it is greater than 0.5. Girls are more likely is what we're looking for this time. Okay, we denote the girls with a positive, so there's 879 of those, and the boys with a negative, so when you subtract that, you get 66 boys. Okay, remember, when we're using this in here, the x is the boys, so the x equals 66 in this case. And we go down here, we want to see our contradictions. We take 879 divided by 945 is 0.930. This is greater than 0.5. This does not contradict our alternative, so we're not going to make a wrong conclusion is what we're looking for here. So now we need to see if this is significant or not. So we go into StatDisk. You're given a number assigned, so we type in, we want to see if it's greater than this time. Make sure you've got greater than here. 0.05 significance, and then your positive and your negative. Okay, when you go through here, we got our test statistic of 66. We've got our mean of 472, our standard deviation of 15, and our critical value of I highlighted the wrong test statistic. I'm sorry. We need to be down here. All right, we're looking at these two, the z-value and the critical z. So we've got a negative 26 and a negative 1.66 are the two we're going to look at. So now, when we go through here, remember this is a left-tailed test, very important. So we're going to put in our z-score, which is a negative 1.645. Okay, remember left tail, so this is the rejection region. And we got a negative 26, so we are rejecting the null. So if we reject the null, that means there is a difference. We already checked that we're not claiming something that's not true. So now we can say there's evidence to support that it does appear to increase the likelihood of a girl, which is really good. All right, next, body temperatures. I would like you to pause and try this one. right, I hope you did a good job. So your null would have been at equals 98.6. Your alternative was less than. You counted your signs. You should have 23 positive and 68 negative. All right, when you check, the 68 over 106 was 0.64, so we are okay. We're going to not conclude anything that's not true. You should have plugged it into StatDisk, and you should have got reject the null, which means we had sufficient evidence to support that the body temperature was less than 98.6. So your test statistics should have been a negative 1.64. And when you did your data, you should have got a sample of negative 0.461. Remember, left-tailed test. So we rejected the null, and that's how we got our conclusion. I hope you did well. Good luck on your homework.